Today, we're going to approach the idea of space-time, that space and time really need to be considered together as one four-dimensional entity. First in special relativity, as it was introduced by Hermann Minkowski, and then in general relativity, where it becomes an essential, ineliminable part of Einstein's theory. Now, Einstein began by being very suspicious of this idea of a mathematical description of space-time as essential to his theory of special relativity. He took classes from Hermann Minkowski and essentially skipped them. He really was not interested in mathematics of a higher sort. He thought they were unnecessary to understand the basic physical facts about the world. Minkowski returned the favor by thinking that Einstein was really not much of a student or promising physicist, and in fact, when Einstein had completed his theory of special relativity, Minkowski was astonished that that lazy dog, as he put it, had done such important work. In any case, from Einstein, we know that the idea of measuring the length of a moving body always depended on measuring simultaneously the beginning and the end. As I keep emphasizing, if you measure a bus going by, you better measure its front and its back at the same time if you're going to get its length as something that's not ridiculous. If I measure the front and then the bus keeps going and then I measure the back, I could say the bus was this big just because I measured the front and back in a non-simultaneous way. So Einstein's criticism of the idea of time and simultaneity and showing that it depended on the relative motion of frames of reference meant that those frames would also disagree about length. And together, the correction of the idea of length and the correction to the idea of length of time and simultaneity made physics fundamentally different and allowed him to produce a physics that was, for electrodynamics and optics, just as invariant under changes of reference frame as it had been for Galileo, just thinking of mechanics. Now, Minkowski himself was an astonishing mathematical figure. He took topics that seemed to have nothing to do with geometry and made them visualizable, made them geometrical. He took, for example, number theory, the distribution of prime numbers or things like that, and showed how number theory itself could be made into a branch of geometry. In the archives that are left from his work and still in Göttingen, you can still see some of the original slides and notes that he made that produced these space-time diagrams. When Einstein saw them, he was really unimpressed. He didn't see why you would want to generalize in this mathematical way to understand a theory that he thought he'd explained perfectly clearly without any of this four-dimensional work. But let's dig in deeper to what Minkowski meant, because eventually Einstein realized that he could not go farther in physics without adopting space-time at the very heart of what he was trying to do. So here, let's look at the nature of space-time, what it is, how it works, and how it can show us in a very clear, visualizable way the relativity of simultaneity, for example, and how it will lead to the basic understanding of relativity that was utterly persuasive to many of Einstein's contemporaries.